Hi guys, I'm Matthew, your VB tutor. Welcome to episode 3 of the Excel Blackjack series. If you haven't watched the earlier episodes or the overview video, I recommend checking those out first. Just click the card at the top to view the full series. In this episode, we'll be covering creating the card class object, generating and shuffling one or more decks, the shape handler module. Alright, let's get into it. Alright, in our code, we're going to set up the sort of basic structure for this first. So let's go right click, go insert, module. We're going to create a mod for the deck. I'm going to create another module for shape handler. And then our last one, this is going to be our mod for the actual game. So we're going to call that Blackjack. And then we're going to have classes. So we're going to have class modules in here. We're going to have a class for the player. And we're going to make cards as their own sort of object as well. So let's card. The first things first, I think we can build our deck. I can show you how we're going to build the deck. So our deck, we're going to have a public deck as a collection. This is going to be the collection used by the rest of the application to say that, you know, that's what our deck entails. We're going to have an enum of our card suit. So we're going to go hearts 0, and then every subsequent one just increases that value by 1. So go diamonds, clubs, spades. Doesn't matter which order these are in, it's just a reference to how things are sort of operated. We do a similar enum for our card values. So we'll go public enum card value. Got ace is going to be 1. 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king. And we'll end that. So each item you've enumerated is going to increase 1 in value if you just set the first. So the ace is going to be 1, 2 is 2, 3 is 3. All the way down to jack is 11, 10, 11, 12, and 13 for jack, queen, and king. Now next we're going to create our generate deck function. So this is going to return a deck so that we can call this and, you know, create a deck that we can start to sort of play with and like iterate or draw cards from and so on and so forth. So we'll do public function generate deck. Now we'll do an optional by val deck count as long. We'll set it to 1, and then that's going to return a collection. So why do we have a deck count? In a lot of casinos and stuff, they actually shuffle, especially with games like Blackjack, they shuffle multiple decks together. So it's actually theoretically possible for you to be dealt a hand with, say, 2 ace of spades. Because you've got, you know, multiple decks shuffled into one. In our game, we're going to use a generated deck of about 4 decks, but this is going to handle that completely dynamically, so we can use it however we need to. So in here, we're going to have a temporary deck as a collection. This is going to be the deck that we sort of fill up in the function itself before we return this to the deck object. And go dim suit as a card suit, value as card value. And then we're going to create a card as a CLS card. Now before we get any further into the generate deck, we're probably going to need to identify what our class card actually is. Because we're building a deck of cards and we need to know what is actually in each card, what properties and everything like that. So let's go into our class card. We're going to need a few properties. We're going to need properties for what the value of the card is, what the suit of the card is, and we'll also need to know whether the card is face up or face down, because the dealer is going to have instances where the card is going to be facing down. We're going to create some private variables here. So we're going to have private p suit as card suit. So this is our enum that we just created in the deck. And private p value as card value. So again, that's the enum we've created here. So just referring to these two enumerated types. And then we're going to have a p face up as boolean. This is going to tell us whether the card is face up or face down. So when our class is initialized, the default state for our face up is going to be true. So we actually want to set that to true. So whenever we create a new card, that card is going to be face up by default. So we're going to need a few properties here. What we can do is actually use the inbuilt procedure builder. So we're going to go property. It's going to be a public property, and this first one's going to be suit. So this is going to be as a card suit, which is our custom enumeration again, and our suit value. So we'll go v suit as card suit. Our get method is just going to set the suit that they've referred to equal to p suit, which is our private variable here, and just the kind of the opposite here. So when we're setting p suit or letting it be a certain value, we're just assigning the new value that has been passed to it to the internal variable. And we're just going to need the same for our value and face up properties. So add those in. We'll do value v value as card value, that, and this one's going to be our face up. Oops, okay. V face up and face up there, and they're just going to be Boolean values, not any sort of fancy enumeration. Now the other thing that might be useful for us is going to be the value of the card in terms of the game, because as I said, the Jack, Queen and King are all counted as 10, but in our enumeration each of those has their own value, 11, 12 and 13. So we're going to create a public property as well. It's just a custom one, get game value. We're not going to do a let for this either, and that's going to be as a long. Now we'll set the game value equal to if p value, the p value is our internal value, is greater than 10, so is greater than the actual 10 card, which is Jack, Queen and King. That value is also going to be 10, otherwise that will just be the value card. Actually, we might even create this as our enumeration, so we'll create that as card value. We'll say if that is greater than 10, then we'll set it to 10. Alright. Now the other things that we're going to need are a couple of custom functions. So we're going to need a public function to get the suit name. So the suit name is going to be create a custom little function here to help return that. The suit name is just going to be select case, and it's going to be the p suit. And so for the case of card suit dot clubs, I'm going to do suit name equals club. So it's just going to be simple like that. We're going to do that for all of our different enumerations. So do diamonds, hearts, spades. And just make them single like that. And end select. And we do the same thing for the card value or the I'm just going to call it the card name. So function card name as a string, and select case p value. So if the card value, if the value is an ace, then our card name is going to be A. Then for Jack, Queen, and King, to J, Q, K. Alright, and else card, return the card name as just the P value. Okay, so that's everything we need in our card class. So now if we go back to our deck, we can start to actually create our deck, generate our deck. So we're going to set our temp deck. Here's a new collection. We have an iterator here as well, I is long. So that we're going to loop from 1 to deck count. This is going to be how many decks we're actually using. XI. And then inside of that, we're going to go for suit equals hearts to spades. Spades. So that's going from this first enumeration to the last enumeration. Next suit, and we're going to do the same thing for our value. So for value equals ace to king. All right. So now we're going to set our card. So we've got our card object here. We're going to set that card object equal to a new class card. Card suit is going to be the suit we've created here. And the card value is going to be the value here. So we're just iterating over every possible combination of, you know, suit and value and creating them in the deck. And then we add that card into the deck. Now here's the problem. What we've created here is now a deck that is always going to be formatted in exactly the same way, or always going to be ordered in exactly the same way. You're going to have the ace to king of hearts, then the ace to king of diamonds, ace to king of clubs, ace to king of spades, and then do that for however many decks that we have. So we're going to need to randomize our deck or shuffle the deck. So we're going to set our generate deck equal to shuffle deck, and we're going to pass in that temp deck object. Oops, and that temp deck is that one, not that deck. So yeah, we're adding the cards into the temporary deck, not into the public deck just yet. Now, shuffle deck, we're going to need to create that function. So let's do that. So we'll do private function shuffle deck. And this is going to take an input deck as a collection, and it's going to return a collection. So it's basically just taking a deck as whatever the deck is currently sorted as, and then spitting it out as a shuffled deck. Give ourselves a little bit of space here. All right, so we're going to do a randomized deck as a collection. Index as long, random index as a long. We're also going to have a temporary list as a dictionary. We need a dictionary because we need to refer to specific keys. I don't think I have dictionary set up yet, so we'll go tools, references, and we'll just make sure that we've got the Microsoft scripting runtime ticked. So new dictionary, that object is now there. We're going to set our randomized deck. Deck. Go to a new collection. And then we're going to iterate over how many items are in the input deck, right? So we're going to go for index equals 1 to input deck.count. Next index. And all we're doing is filling up this temporary list, so this dictionary item, with each of those items from our index. So we'll do temp list.add. The key is going to be the index, and the input, and the item is going to be the input deck index. So remember, our input deck is a collection. Each item in the collection is a card. So essentially we're just adding each of those cards into this dictionary and indexing them with the index value that we're iterating over. Now here, before we actually create or sort of randomize the values that we're doing, we're going to actually call the randomize statement. So what this does is it just ensures that the randomness is seeded each time the function is called, which prevents repetitive patterns. You know, when you're re-randomizing or reshuffling the decks. So we'll do while a temp list.count is greater than 0. So what we're going to do is we're going to loop through this temp list and remove things as we go. Okay. So our random index is going to be an integer of the temp list.count times the random value plus 1. This is just going to give us a random number of the items that are actually currently in the temporary list. We do randomize deck dot add, and we refer to temp list dot items, and the items is going to be the random index minus 1. So this is just getting a collection of the items and then referring to the item in that collection. And then we do temp list dot remove, and we just remove that item from the list. Okay. And we set our shuffle deck item here equal to our randomized deck. And that's all we need to do. So that's now shuffled our deck into a completely random order. So I'll show you how this comes together. So what we'll do is a quick test function. So we'll do sub test deck, do dim, we can just use this deck. So set deck equals generate deck. And we'll just leave that as 1 for now, just so you can see what's happening. So we'll run that code. That will jump in here into the deck. So let's have a quick look at that deck. So we'll go temp deck. This is what we're actually spitting out at the end of this generate deck function. So item 1 here, ace of hearts, 2 of hearts, 3 of hearts, 4 of hearts, and so on. As we jump out of that, go into the shuffle deck. By the end of shuffle deck, we can have a look at our randomized deck item. We can see here now we've got 7 of diamonds, 9 of clubs, 5 of spades, 7 of clubs. So it's completely randomized that deck. And the beauty of doing it this way is now that if we want, we can go, okay, we want 5 decks. So we'll run that, and then you can see that our deck object, we now have 5 times 52 cards, 256 items, and all of them are completely randomized and completely shuffled together. Before we move on to creating our player class, let's quickly set up the shape handler module. Our shape handler is just going to make it easier for us to refer to shapes. So rather than doing sheet game dot shapes button restart or whatever the things might be, we'll just create a function that called button restart that returns that shape, right? So public function button restart as shape, set button restart equal to sheet game shapes button restart. Okay, we're just going to do that for all of our different shapes that we have in our form or in our game, or specifically mostly for the buttons. So I'll just quickly do that. All right, so we've created those. Now, personally, I just find it a lot easier to create a custom routine to handle setting shape text, because that gets messy because you need to refer to the sheet, the shape, text frame to text range dot text equals the text value. So rather than do that, I just make a simple routine that does that all for me. So we'll do public sub set shape text 5val shape as string. That's going to be the shape name, and 5val text as string. Oops. Okay, so we're going to get our shape name and the text value there. We're going to do sheet game dot shapes, shape name there, text frame to text range dot text equal the text value. We'll do the same sort of thing with the visibility of the shape, because we'll need to be setting that on and off with like our messages and stuff like that. So set shape visibility, shape and state as a boolean. Actually, we'll set that as MSO tri-state, because that's what the visibility state accepts. Now, we don't want to set our visibility state to something that's already set to. So that just increases the load on the system. So we just don't need to do that. So we'll do if sheet game dot shapes shape visible does not equal the state we've been passed. Then we'll set the visibility equal to the state. That's it. So that's all we need for our shape handler function, shape handler module. Thanks for watching. Please hit that like button if you're building along, and subscribe so you don't miss the next episode. In the next episode, we'll cover creating the class player object. As always, the final product is available on my Patreon for one-time purchase or for free to second tier members. Thanks again for watching. This is your VB Tutor signing out.